All right, let's talk about something pretty amazing today. We're going to uncover a kind of secret formula for control, this hidden principle that, believe it or not, quietly runs almost everything in our modern world. So, let's start with a question you've probably wondered about. How does cruise control actually work? You set your car to, say, 65 miles per hour, and it just stays there. It doesn't matter if you're going uphill, downhill, whatever. It honestly feels like magic. But it's not magic. It's just a really, really brilliant piece of engineering. And get this, the answer to that cruise control puzzle, well, it's the key to understanding so much more. This is not just about cars. It's a huge, fundamental concept that explains how we command machines to do exactly what we want with just incredible precision. To really get how we achieve this level of control, we first have to meet the thing we're trying to control. In engineering, it helps to think of any physical system as, well, kind of like a wild beast. It has its own way of doing things. And our first job is to understand that beast. Okay, so let's start with a classic example, one that engineers call a mass spring damper system. Sounds complicated, but it's not. It has all the basic parts we need. Just picture a weight hanging from a spring, and maybe there's something like a shock absorber attached to it to slow it down. Let's break that down, right? The mass is easy. It's just the heavy object. The spring, well, you know what that does. It gives it that bouncy, stored-up energy. And the damper, that's just like the shock absorber in your car. Its job is to resist motion so things don't just bounce around forever. Now, if you go and poke this thing, it's gonna react. Of course it is. It'll bounce and wobble, and eventually it'll settle down. But notice something important. It has no goal. It's completely passive. It's just reacting to the world. This is our untamed beast. So if we want to tame this beast, we can't just guess what it's going to do. We have to be smarter. We have to learn its language. And in the world of engineering, that language is mathematics. We need to find the system's secret formula. And the process for this is actually really logical. First, you just watch it. You observe exactly how the system moves. Then, you use physics and a bit of calculus to write down some equations that describe that motion perfectly. But here's the magic trick. You then boil all that crazy math down into one single beautiful formula. And this secret formula, it has a name. It's called the transfer function. You can literally think of it as the system's personality or its unique DNA. If you know the transfer function, you can predict exactly how that system will behave, no matter what you do to it. And this lets us think of our whole system as just a simple block. You give it an input, like a push. That push goes through the block, which has the rules of its DNA inside, and what comes out is a perfectly predictable output, the wobble. We now understand the beast. But, understanding isn't enough, is it? We want to control it. We want to make it do what we want it to do. And to do that, we need to go beyond just a formula. We need to give our beast a brain. I mean, look at the difference here. A system on its own, it's passive, it's aimless. But the second we add a controller, the whole game changes. Suddenly, the system has a goal. It starts measuring itself, noticing when it's off track, and it's constantly making these tiny little corrections to get back on course. And this brain has a formal name, of course. It's a controller. Its job is so simple, but so powerful. It's always asking two questions. Where am I supposed to be, and where am I right now? And if those two answers don't match, it takes action. It is literally the beast tamer. So let's bring this all the way back to where we started. How does all this stuff, masses, springs, controllers, explain your car's cruise control? Well, believe it or not, a car, with its engine, its suspension, its weight, and all the forces like wind and gravity acting on it, is really just a very, very complicated mass spring damper system. It's our beast, just a much, much bigger one. So here's that control loop happening in real time. You set the goal, 65. Then a disturbance happens, a big hill. The car's speed drops to, say, 63. The controller immediately sees this error. It knows the difference between 65 and 63, and it takes action. It tells the engine to get a little more gas. The car speeds up, and right as it hits 65 again, the controller backs off, holding that speed perfectly. And once you see this pattern, this little dance of goal, measurement, error, and action, you start to realize we live in a world that is just full of these tamed beasts. I mean, really think about it. Your thermostat at home. It has a goal temperature, and it controls your furnace. A drone holding its position in the wind? Yep, its motors are constantly adjusting. An airplane's autopilot, a factory robot, they're all running on this exact same fundamental idea. And that's really the secret formula. It's so elegant. First, you have to understand the beast by finding its transfer function. And then you design a controller, a brain, to guide that beast toward any goal you can possibly imagine. So, the next time you see a machine doing something with perfect precision, you'll know the secret. You'll know it's a beast that's been understood and a brain that's been built to tame it. Now that you can see the pattern, what else are you going to find out there that's secretly a controlled system?